last review topic that we're going to cover. Okay, this is the stuff you probably don't have a ton of experience with this. This is the stuff you probably would have done maybe more towards the end of Algebra 1. So what are we talking about here? We're talking about quadratic trinomials, and so they're always going to be written like that. They're going to have the form x squared plus bx plus c, but the b and the c could be positive or negative. So they might actually end up looking like any of these four cases. X squared plus bx plus c, or x squared minus bx plus c, etc. The b or the c could be negative. All right, and our goal is to break these things apart. Now, I want to put this in a little bit of context here. The stuff that we've been talking about the last couple days, when we do things like this, when we do things like multiplying polynomials, right? How did we go about doing that? Or what did we say we did with these? We distributed, sure. We took the x and we distributed the x to both of those two terms and got what? X squared minus 3x, very good. And then we took the 1 and we distributed that to both terms, and we got
x minus 3
plus x minus 3. And when we combined like terms, x squared is different, but the two x's are like terms, aren't they? So I can combine both of those to get x squared minus 2x minus 3. Okay, and so we're able to say something like this then. We can take our quantity x plus 1 times the quantity x minus 3, and that's equal to the polynomial x squared minus 2x minus 3. And you might remember that we said that process of going from there to there we called expanding. Okay? In math, that's expanding. When we multiply stuff out and we get a whole bunch of terms that are just added and subtracted. Okay? Now, what we're going to look at today is the reverse process. If we start here and we go back to there, that's unexpanding, but we have a name for it. We call it factoring. So it's literally the reverse process of the stuff we talked about last. Okay? This is pretty easy to do, though, and I think you're going to find this. Once you get into this assignment, you get a little practice, you're going to think that that multiplying polynomials assignment is not too bad. Factoring is a little trickier. Now, we're not going to do any real complicated factoring. We're just going to do relatively simple factoring, and we'll do a lot more of it in Algebra 2 that's harder. But here we go. So how do we do this stuff? Oops. Okay, so we're going to look at a couple different cases here. We're going to look at one case where the two numbers that show up, the b and the c, are both positive. Okay, like that. Okay, remember that's x squared plus bx plus c. So b is 10 in this case and c is 16. So how do we deal with this? Does anybody remember how we do this stuff? Yes, ma'am. What do you think?
Don't we have to find out what two numbers make like whenever you multiply them together make 16?
Okay, and what else? That's part of it. We got to find two magic numbers that multiply to 16 and say the last part again. Okay, add to 10. Good. We want the two numbers that multiply to c and add to b, right? So those two factors. Now, what would they be? What two numbers multiply to 16 and add to 10?
2 and 8.
2 and 8, sure. Now, we can look at all the, there's a bunch of different cases to consider. All the factors of 16 are 1 and 16 and 2 and 8 and 4 and 4. Of all those possible numbers that multiply to 16, the only ones that work in this case are obviously the 2 and the 8. right? Okay, so those are the numbers that we attach to the x's in the factored form when we break this thing apart. Come on now. Those are the numbers that get attached to the x, right? So x plus a times x plus 2 is the factored form of this polynomial. This we call it trinomial, 3 terms, quadratic trinomial. How could we check to see if we did it right? Yeah, expand it out, distribute. See if when we FOIL that out or distribute that out, we get that answer. Okay? So not that big a deal. Okay, case 2. B is positive. I don't know why that A is up there. Forget the A. B is positive and C is negative. Okay? So here's our example. X squared plus 5x minus 14. What are our numbers here? What do they have? They have to multiply to what? Negative 14. Good. And add to 5. Okay. Now we can get a little bit of a head start on this one. And these are pretty small numbers that can be pretty easy to deal with, but they could be harder. Now when we're building our factors here, we can get a head start on this. We can always write out the template. And that's what I'm going to call this, writing out the template of the answer. You know it's going to be 2 factors. You know there's going to be an x there. And all we need to find are the magic numbers. But we can play a little sign game that helps us out. Now, if the 2 numbers multiply to negative 14, what's one thing that you can tell me about those for sure? Okay, one's negative, one's positive. They have to be opposite signs because only positive times negative gives us a negative answer, right? So they're opposite in sign. There's another thing we can tell, though. When I add those up, if they add to a positive result, if they're going to add to 5, which of the 2 numbers has to be bigger, the positive or the negative? The positive does, because when I add them up, the positive is going to dominate. The negative is going to get absorbed by the positive, and we end up with a positive result. So the way I like to do this, then, is to put the biggest one first, which we know is positive, and the smallest one is negative. And so that helps a little bit. Now we have a head start on this stuff. And so now we know we're looking for a big positive number and a small negative number. And what are they? 7 and 2, sure. If you want to get into a little more detail with that even, how much bigger is the positive one than the negative one? Now, does that question make sense? We know that we've got a positive and a negative. We know the positive one is bigger. But when I add up positive and negative numbers, think about what that looks like. If we illustrate that maybe with, here I know how we can do it. Let's do this. What if I have 2 numbers? I've got positive 9 and negative 3. When I add those up, what do we do with them? I mean, that's a bad question. Well, what's the answer? 6. Okay, now think of it this way. What if I took this guy? Oh, can't do it. What if I just move that red arrow over here? So I add those 2 numbers up. I'm going to go over 9 and then back 3. Right? The negative is eating away part of the positive, right? And I end up with an overall result. Oops, that's positive 6. So the negative, the only point I'm making, and that maybe that's not the greatest example, but the only point I'm making here is that the negatives and the positive partially offset each other. And whichever one was biggest to begin with wins. But how much bigger it is the final answer, isn't it? Right? So doesn't that mean then that when I look at these numbers, if I end up with a positive 5, the positive number had to have been exactly 5 bigger than the negative number. That kind of helps, doesn't it? Right? So we know how far apart the numbers need to be. And in this case, like I say, it's so simple that we just get right to the answer. But if these were really complicated numbers, like big numbers in the thousands maybe, then it gets really hard to think of the factors of those numbers. It's almost easier to think of, I'm going to look for 2 numbers, well, how far apart are they? And see which ones multiply to give me the right answer. And we'll look at an example like that eventually, where it's a really hard one like that. But do you see the point I'm making? that tells me how far apart they are. 7 is 5 bigger than -2. Okay? Questions on that? Okay? Oops. Okay, so did that change? Oh no, it didn't. Never mind. Oh, never mind. So there are my answers, right? And it looks like that. Okay. Magic numbers just go in there with the x's. Okay, next example. Okay, what if b's negative and c's positive? Something like that. Okay, look forward. There we go. B's negative and C's positive. So what about, can you tell me about this one? What if I get something like this where I've got a positive 36 at the end, so the two numbers multiply to positive 36, but they're adding to negative 13. Now what does it mean if two numbers multiply to give me a positive result? That by itself only tells me what about the numbers?
Both numbers are negative.
Both numbers are negative in this case, but let's pretend we're not even bothering with the negative 13 yet. If all we know is that two numbers multiply to give us a positive result, what's that telling us about the numbers? They're both negative or they're both positive, right? Does that make sense? Yes, sir. Is that what you're going to say? Okay, so then in this case, if they're adding to a negative number, which one must it be? The two negatives, right. What is the answer?
-9, -4.
Yeah, so we just got to find two numbers that are both negative that are going to multiply to 36 and add to 13. Only it's negative 13 because they're negative, right? And so we got it. Out of all the possible factors of 36, the ones that fit are the 4 and the 9, but they're only going to be, we just need them to be negative, right? So we'll pick those. Okay, and there's our answer. Okay, and then the last example, this guy. Okay, so if they multiply to negative 20 and add to negative 8, what can you tell me about the two numbers? We can write our template with the x's there. If they multiply to a negative, what's that tell me? One's positive, one's negative. Which is bigger if they add to a negative? The negative. And what are they? 10 and 2. Okay, no big deal. Okay, so there you have it. Now, the next step is, so factoring is no big deal really. I mean, especially with small numbers like this. But why do we do this in the first place? Okay, well, here's the whole point of factoring. The whole point of factoring is so we can answer questions like this. What if we have x squared minus 3x minus 18 equals 0? Okay. We're going to talk a lot more about this in Algebra 2, but I want to get you just thinking about this a little bit now. Now, when we're solving equations, remember, we've done a lot of that this year already, only the equations look different. They looked easier. They were linear equations. Even if we had a problem, let's leave this one for just a second. We'll come back to it. Let's remind ourselves about the stuff we have done. What if I had one like this? 2x plus 3 equals negative 2x minus 9. And I want to solve for x there. What do I do? What do I do to solve for x? You got to combine like terms. Which side are we going to push the x's to? Okay, go to the left because I'll have more of them there. So we'll add 2x to both sides. Right, and then will go away, and I'll get 4x plus 3 equals -9. And now this is good, right? Because now I've got a single x I can point to, so I can isolate it. And you've done a ton of these by now. What are the two steps I would do in order to get that x by itself? Okay, subtract 3 and then divide by 4. What would my answer be if I did both of those things? So you can do it in your head. -3. I'm going to get my -12 divided by 4. So x is -3. Okay. Now this problem that we're now working on, this looks a lot harder. What's the big difference here? Okay, 18. Say it again. 18 maybe should be on the other side. Okay. But even if I put the 18 on the other side, there's still another big difference here we're still kind of stuck.
X squared.
I've got x squareds and x's. So how can I isolate a variable, right? I don't have the luxury here of being able to combine like terms and get a single x anymore. This is a different kind of problem. It doesn't work. We can't isolate x here. We need a different strategy. And this is a lot of what we do in Algebra 2 is deal with situations like this. Well, here's our strategy. If we could factor this thing into, if we could factor this into a product of two factors, then maybe we can find an end around here. We can find a tricky way to get answers other than isolating x. Does this factor? In other words, can I take this quadratic expression up here and rewrite it in a factored way? What's it equal to if I factor it? Well, by the way, not everything factors easily. There aren't always magic numbers that work. Sometimes we'll run into cases where we just can't find them, and then we've got to do something different. But we're going to only, this year, for our review purposes, focus on cases that do work. So I can write my template. Now, do magic numbers exist that work for me here? What would they have to multiply to? -18 and add to. Okay, so then what are the signs of the two if they multiply to a negative? Negative and positive. If they add to -3, which is bigger? The negative. So what are they?
-6 and 3.
-6 and 3. Okay, now this is huge. This is very helpful to us. It's a great trick. Because we were able to factor this, we got a tricky way to find the solutions. Now we're gonna just to warm up, we're gonna do a little mental math here. Okay, I want you to follow along, don't write anything down. I want you to just follow with me and keep track of this mental math as we go. Okay. Start with 5. Okay. Thank you. Plus 3. Okay, get the answer. Times 4. Okay. Times 19.519 times 1,009,417.39418. Okay, with me? Times 0 equals 0. Okay, doesn't matter how complicated the number gets. If I multiply by 0, the answer is always 0, right? In fact, if I'm multiplying two numbers together, what's the only way that I can get an answer of 0?
0.
If one of the numbers is 0, right? It's the only way it can work. There's no way I could multiply two numbers together and get an answer of 0 unless at least one of those two numbers is 0, right? Now look at this then. So if we know that the quantity x minus 6 times the quantity x plus 3 equals 0, what does that tell us about those two factors? Well, not necessarily x equals 0, but these are the two things that I'm multiplying together. I've got the left hand times the right hand stuff, right? Whatever's behind my left hand must equal 0, or if it's not 0, what's behind my right hand has to equal 0. Make sense? That's got a name in math. It's called the zero product property. And what it says is just if I have a product of things that equals 0, then the only way that can work is when the individual factors are 0, right? So there's what values of x could make this whole thing equal 0. Well, two things could be true. Either x minus 6 would have to equal 0, right? Or x plus 3 would have to equal 0. Does that make sense? Okay, and then those are easy to solve. What's the solution to this equation? X equals 6. Or what's the solution to this one? Okay, how about that? So we probably could have gotten those a little quicker by just asking ourselves the question, what value of x would make that first factor 0? Well, 6. And then what factor, or what value of x would make the second factor 0? -3. Okay, tricky, huh? But the essential part of that trick and that solution was being able to factor the quadratic. That's what allowed us to get those answers, right? We had to be able to break it apart into a product of two factors instead of a sum of a bunch of terms. Just looking at this original statement up here, I mean, you're going to be trying forever if you're just going to guess and check numbers that are going to somehow make all three of these terms add to 0, right? The only way we can get to it quickly is if we can break it apart into factors and then set the factors equal to 0, right? So I'm going to give you a problem to work on here, and then we can probably call our quits after this one. Everybody get out your notebooks and just try this. I want you to solve. Do that right? Let's see. Yeah. Okay, I'm trying to pick harder numbers this time a little bit. I want you to solve this quadratic equation. Okay, take a second and work on this, and then we'll go through this whole groove. If we can do this, we've done some good stuff. I think we're done. We finished? Just another minute. Okay, let's talk about this one. If you're not quite done, that's okay. We'll just finish it up together here. So, what's our strategy? What do we want to get this answer? What do we have to be able to do? We can't isolate x, so what do we have to do instead? We got to factor it. Got to break it apart into factors. So we already know that it's going to look like this, right? And this is a good idea. Let's write down as much as we can, and we'll fill in the specifics. So there's our template. We'll fill some stuff in. We know that's an x, and we know that's an x, right? And why do we know that, by the way? I guess I just kind of told you that, but if we think about it for just a second, we'll see why. When I FOIL these things out or distribute, when I distribute this x over to this x, that's going to give me that x squared, isn't it? Right? So when I FOIL first times first or distribute, that's why I need to have those x's there, I guess. But we need the magic numbers. So what do they have to do? Both have to be negative. They're going to multiply to a positive and add to a negative, and they got to multiply to 52, right? So we got to find the factors of 52 that are going to add up to 17, both negative. Yes, sir. Oh, hold on one second. I'll get to you in just a second. You got dibs on it. Now, to get this answer, how did you guys go about getting the answer? What'd you do? What's your process for getting the answer, somebody? What do you think? What'd you do, Woz?
I just basically times something by the 17 and then added the 52 to find
Okay, so so they gotta multiply to 52. So are you saying you found numbers that added to 17 first? Oh, okay, you did the factors. Okay, but they have to multiply to what? Go ahead. You got a good start. Help us out.
I go like 1 times 32 is 52.
Okay, good idea. Is that us? Oh my gosh. Okay, we'll finish up this last one tomorrow, and then you guys get the work day.